Hi, my name is Mary Julian,
And I'm Alec Cromer.
and we're sharing our image synthesis project for CSCE 647 and ESA 656. This builds on the project 2 from we're creating a surface in 3D, diffuse lighting, specular highlights, caustic, as well as adding textures and backgrounds. From project 1, you can create a cool shape using Hermitian curves with a Coons patch to interpolate the shape. By moving any of these points, you can change how the curve goes to the point. You can also now use the WASD key to rotate the right-hand side. So the right-hand side is the final rendered image. Using the minus and plus key, you can raise or lower the point in the Z direction. Alec will talk a little bit more about the lights, but just like the points on the surface, you can change the position of the lights. And that will update the caustic as well as the shading and the specular highlight. So new to project 3, we've added this specular highlight. And then you can see moving on the shape. The depth has improved, so now the depth is more of a smooth transition. You can also change the background image here. So we have 6 different options. We have gray there, blue, maybe in the future we'd allow the user to upload images directly. So if they have an image they want to use, they could change the background. Just like before, you can modify the surface color. Yeah, thanks. And then Alec will talk about the lighting and the textures. Thanks.
Yep, and for this project, we additionally added a secondary light on top of the first one. You were able to select the different colors for both light 1 and light 2 individually, so you can come up with some pretty creative colors, and then you can move the lights around and create a more dynamic image. On top of that, we added a surface texture option for the surface itself. And you can combine that with the different colors and the surface color to make something kind of unique. We have right here is the Voronoi. This is based essentially off of project 1, where I have a piece of code that was able to generate this Voronoi, and we were able to place it and light it dynamically based on the 2 lights. We also have a Voronoi mountain. This one is kind of a more dynamic Voronoi shape. This one itself was built in Houdini, and with a set of nodes we were able to create and then wrap the Voronoi onto a transfer map and then place it into this application. We have other unique textures on here. We have like sheet metal, fabric, wood, and then one that we just added was the A&M campus. It actually features the quad, and I think Langford C is probably on here. It's a little hard to see with the surface color right now, but if we actually decrease the surface color to something more dark, it'll pop up a little bit more, especially with maybe different lights. Yeah. Okay, I'll pass it back off to Mary to continue on.
Thanks, Alec. Let's talk about the code a little bit now. The main change to this project from the previous projects was to the shader. So previously we were using the vertex shader to do most of our colors and our shape changing. This is now moved into the fragment shader so we can get a pixel by pixel updated shape. So the specular color is calculated in the fragment shader for both the light 1 and light 2. So if we go to specular color, you can see where we take the I vector. So this is the camera's position minus our pixel position. The light vector, and these are both normalized. We grab the reflection from it and calculate the specular power, the specular strength of the reflection. And that's returned and added together. We also do a similar thing for the texture. So we grab a texture map. We have a list of textures. If you go to normal, you can see that we just have PNGs with the RGB texture map that we sample, and we grab that sample, we add it to the original normal, and then we calculate the diffuse lighting by just doing a dot product with the normal value and the light. Adding the specular and the diffuse lighting gets us our output, and that's what gets shown to the user. That's the math part. The rest is UI manipulation and allowing 3D for the depth. This will be available on my people.tamu website for you to use. It'll be linked in the README of the code. Thank you very much.